This is the apparatus that we use for electrolysing water. So you can see it's got some connections on the back here, but effectively this is what we call the black rod, the cathode. This is the negatively charged electrode, and over here this is the positively charged electrode, the anode. Now you can see inside there's a little coil of wire and a little piece of platinum up at the top of the electrode, and that's allowing the electrons to be released at this cathode and to be absorbed at this anode. Okay. Now in the whole system, in this piece of glassware, I've actually got a solution of sulfuric acid. Now, although we call this electrolysis of water, we're strictly electrolysing sulfuric acid, but very often in GCSE exams they say that the sulfuric acid there is only being used as a catalyst. Now, I'm in some dispute about whether that's true or whether that's accurate to refer to that, because a catalyst is something that's supposed to speed up a reaction, but this reaction fundamentally wouldn't happen without the sulfuric acid there. So it's a bit debatable about whether we're allowed to call that a catalyst, but for the purposes of your GCSE exam, it is a catalyst. So what I want to do is to have a think about which ions we've got present in this solution of sulfuric acid, and therefore what we're going to have forming at this cathode and at this anode. So now that it's zoomed in, I hope that you can see we've got bubbles coming off the cathode here, and bubbles also coming off the anode here. And as we scan up, you can see that we've collected some gas on this left-hand tube, and we also collected some gas on the right-hand side, but it's clearly producing far more gas on this side than it is at this electrode. So I want to just pause now and have a look at which ions we've got present in that solution and why we're getting these gases forming at the different electrodes. So in the solution we have got obviously water and some sulfuric acid. Now what I want to do is to have a look at the different ions that means must be present in our solution. The sulfuric acid has got H+ ions, obviously, because that's what makes it an acid, and sulfate ions, SO4 2- ions. And the water potentially could be split up into an H+ and an OH-. So these are the three ions that we're going to have present in that solution, in that liquid: H+ ions, OH- ions, and SO4 2- ions. So hydrogen, hydroxide, and sulfate ions. Now, if we think about the charges on the electrodes, the cathode has a negative charge. So the only ion that's going to be attracted there is the H+ ion. So you might like to have a think about what could form at the cathode if we get H+ ions going there. Now for the anode, which has got a positive charge, the two negative ions are going to be attracted there. So the hydroxide ion and the sulfate ion. Now you might remember from when we did our electrolysis of solutions what happens when we have sulfate ions present in the solution and what we form at the anode instead. And this is because there's effectively a competition between the sulfate ions and the hydroxide ions about which one is going to get discharged first. And the hydroxide ion is discharged more easily, and therefore the hydroxide ion does slightly complicated reaction, but is able to discharge and produce oxygen from that. And I'll show you the equations shortly. This is the reaction that's happening at the cathode. You can see the hydrogen ions are going there and they're gaining electrons. And as a result of that, we're producing hydrogen gas. Now you might like to think about whether that process is oxidation or reduction. At the anode, we have the hydroxide ions being discharged. Now to discharge the hydroxide ions, we need 4 hydroxide ions to go there, and they will lose 4 electrons. So each hydroxide ion effectively loses an electron. They recombine to produce 2 molecules of water and a molecule of oxygen. Okay. Now you might also like to have a think about whether that process is going to be oxidation or reduction based on what's happening in terms of the electrons. Now what we're going to do now is to go back to our apparatus and have a look at the quantities of hydrogen and oxygen that we've produced. If we have a look at the volumes of gases that we've managed to collect from our electrolysis of water, you can see that in this side where the hydrogen was collecting, we're down to about 22 centimetres cubed. And on this side where the oxygen was collecting, we're on around 11 centimetres cubed. So we're making twice as much hydrogen as there is oxygen. And this is why we call it electrolysis of water, because if you think about the formula for water, obviously it's H2O. So twice as much hydrogen in the formula as there is oxygen. And we see the evidence of that here in terms of the proportion of hydrogen to oxygen that's collected when we electrolyse it. Now in a minute I'm going to let some of the gas out and collect it into a test tube and prove that I have in fact got hydrogen in this one and oxygen in this one. So I'll just collect those and then I'll come back to you to show you the tests. So these are the tubes of gas that I've collected from the anode and the cathode. I'm going to test the one from the cathode first. This is the one I suspect has got hydrogen in it. So I've got my lit splint here ready. I'm just going to do my test for this. turn it upside down. And then I'm going to hold the lit splint underneath, and I hope, yay! I get a squeaky pop. So that's fairly convincing, I think, that I did have hydrogen collecting at the cathode. So this is the tube of gas that I collected from the anode, and this is the one I suspect is oxygen. So I'm going to test this one with a glowing splint. So again, I've got my splint here ready. Let's get my gas tube ready as well. And I hope it relights, which it did. Let's see if we can get it to go again. Not quite. No. But I think that was convincing that we had some oxygen in the tube we collected from the anode as well.